Alright guys, today's video is over special products. And so what we're going to do is we're going to look at three special cases that we have when we are multiplying two binomials together. So if you will, just take a second and write this information down in your notes. Press pause, write it down, and then join us whenever you're finished. And we're going to talk about what all of this is. Alright, so we have perfect square trinomials and we have difference of two squares. Those are two special cases of problems that we are going to have, and we're going to look at each of those separately now. So the first one is when you have a problem that's given in the format of a plus b and that quantity is squared. The a and the b are numbers or they're variables. Alright, so what you do whenever you have this problem is you end up every time with an answer that's going to be whatever your a value was. You're going to take that and it's going to be squared. That's going to be the first term in your answer. Then your middle term is going to be 2 times whatever your a and your b are. You're going to multiply those two values together and it's going to be 2 of those. Then your last term in your trinomial is going to be the value of the b squared. Okay, so what does that look like in a problem? Let's take a look. So here I have the problem x plus 3, that quantity squared. So this problem fits with my form a plus b squared. So my answer is going to be whatever the a value is. The a value is the x. So it's going to be x squared plus 2 times whatever the a and the b multiplied together are. So this is the a and this is my b. So what is 3 times x? It's 3x. So it's going to be 2 times 3x, and then my last term is going to be the b value, which is 3 squared 9. So now if I clean this up a little bit, I'm going to get x squared plus 6x plus 9. All right, so that is what you get when you multiply x plus 3 times x plus 3. All right, that is the exact same thing I would get if I were to work out the problem like we have been doing in class, where I distribute here and then combine my like terms. It's just that this is a special case, and so it's one that we can recognize quickly when we see the problem. So when I see this problem 4s plus 3t and that quantity squared, I recognize, oh, this is 4s plus 3t times 4s plus 3t. It's the same binomial 2 times. So that's going to give me a special answer. And that special answer is whatever my a term is, which is 4s squared. So what's 4s squared? It's 4s times 4s, 16s squared. Then I have 2 of whatever my a times my b is. Well, a is 4s, b is 3t. Multiply those together. 4 times 3 is 12, and s times t is st. And then I'm going to have whatever my b term is, which is 3t squared. 3t times 3t is 9t squared. Now we just clean this up a little bit. 2 times 12st is 24st plus 9t squared. So again, it's a faster way to get to your answer once you recognize that it is a special product. Let's look at the next one. This is when our problem is a minus b squared. So we still have the squared on the outside. We still have a binomial, but this time instead of addition being in the middle, it's now subtraction. So you should notice from this slide to the last one, the only difference in the formula is this middle term right here. Instead of doing plus 2ab, you're going to do minus 2ab. So let's apply that. I'm going to first, I see that it's a difference here. So I know my middle term is going to be subtraction, right? Because it's subtraction right here. This is my a, this is my b. Now let's apply those. So first thing I do is I take my a term and I square it. 4m squared is 16m squared. I have a minus sign in the middle, and then I need to do 2 times whatever my a times my b is. So my a is 4m times my b is negative 10. That gives me, just 10, because we've already accounted for the subtraction sign right there. So 4m times 10 is 40m. And then I have plus my b squared. My b is 10, and so that squared is 100. So when I simplify this, I have 16m squared minus 80m plus 100. And that's what you would get if you worked it all out the long ways. One more here. 2x minus 5y squared. So I have the subtraction sign in the middle, so I know I'm going to have subtraction before my middle term. I take my first term, the a value, and I square it. 2x, that quantity squared gives me 4x squared. Then I have my subtraction. Then I take 2 times the a times the b. So 2x times 5y. 2 times 5 is 10xy. And then I'm going to have plus whatever my b value is, which is the 5y squared, 25y squared. Now when we simplify, 4x squared minus 20xy plus 25y squared. All right, let's go on to our very last case. And this is when we have something that looks like this. A plus b times a minus b. So remember, the a's and the b's are numbers or letters. Okay, so the difference is that I have the same number in this spot as I do in this spot. I have the same number in this location or letter as this location. Okay, the difference is that I have one plus sign and one minus sign. So something special is going to happen here, and that is that the middle term that we usually have is going to cancel out completely. So our answer is only going to have 2 terms in the end. Let's take a look at an example. See how I have a 10 here and a 10 here? They're the same. I have a b here and a b here. They're the same. This plus sign and this minus sign right there, that unique situation is going to cause my middle term, that 2ab part that I usually have, to cancel. So my answer here, I just take the a term, which is 10, and I square it. I get 100. Then I put a subtraction sign, and then I take my b term, which is a b, ironically, and I square it. That is my answer. Okay? This is what we call a difference of squares. A difference, because it's subtraction, of 2 perfect squares. Let's take a look at the next one. I have the same term in the a position. They're both p squareds. I have the same term in the last position, the b position, 8q's. Why is it unique? Because I have a plus sign and a minus sign. It's not unique if they're both plus signs or if they're both minus signs. But if we have the one positive and the one negative, we know our middle term is going to eliminate. So my answer, I take my a term, which is p squared, and I square it. P squared squared gives me p to the 4th. I always am going to have subtraction in my answer. And then I take my b term, which is 8q, and I square it. 8q times 8q is 64q squared. Now keep in mind, guys, these are the exact same answers you would get if you work the problem out the long way, where we are multiplying or distributing 4 times to get our answer. The situation here is we want to get to the point where we recognize these special cases and we can work them quickly, okay, because it's going to help us a lot down the road.